me, and I would select one of them for you to read it, understand it, and then make presentations slide for it. And then we would make up some time for you to present it to me, like maybe in 15 to 20 minutes. And then I will ask you questions. And depending on how much you understand the topic, you will earn some point. So I mentioned it here that it is going to be a paper presentation. Last semester we had suggestions that somebody wants to write a report. Somebody has experience and they want to share that. And I'm saying that those are unfortunately not acceptable. I don't want a report. I don't want your personal experience. I want you to be able to read somebody else's work and be able to understand it and answer questions. So that is the way that you can earn some extra points for yourself. Also, you will have a chance to do implementation. For the paper implementation, again, one of the idea is that you go ahead, find a paper, and then you start to implement it. Implementation of some basic algorithms, crypto systems such as RSA, AES, or those algorithms, are not acceptable. In terms of implementation, we expect you to really get your hands dirty and do a really good amount of work and implement some really interesting protocol or crypto system that maybe the implementation is not out there or is out there. It doesn't have all the features, and then you want to contribute to those features. So it really has to be something that's worth it. So this would become challenging for some of the students. So that's why most of the students in the past that they decided to go with the bonus points, they decided to go with the paper presentation. And also that is my recommendation to you. So the last, never the least, the textbooks that we have for this class. Normally, I will have enough material for you to study, understand, and get yourself ready for the exams. So if you really understand the materials and participate in a class, I don't think you will need to have access to any book. But I also understand that a lot of you, maybe like myself, enjoy to read the books. So if that is the case, I really recommend you to take a look at this book number 1. It is one of my favorites. I've read it many times in my life. I really like the style of the author, and it never gets you bored. And it is not a very lengthy book. And unfortunately, this book is not available in Taiwan. I talked to a number of publishers in Taiwan, but unfortunately, I was never able to get them to bring it to the library for you to purchase it easily. Maybe the story has changed, I'm not aware of. But if you just Google this book, unfortunately, I can't share the link with you, but it happened that the author already put this book there for free. You can just download the PDF and read it, or if you want to, you can print it at the university. So those are the options for you. And if you have the second and the third book, you're also good to go if you read them. The second book is a little bit lengthy. It is 2 volumes and probably more than 1,000 pages. I'm not sure if you have the time to go through this throughout the semester, but it has a little bit of more examples and more details on every topic. But generally speaking, if you are interested to read a book, I would really suggest this book number 1 for you to read. Other than that, if you have a busy semester, we have enough coverage of this book on the slides, and just reading the slides and having my annotations would be enough for you to accomplish your goal for the semester. All right. These are our goals for this semester. So before I go forward, I want to ask a different type of question. So many of you, this might be your very first class in English. So I want you to answer me. Do you think I talk very fast? Do you understand me? So I think after talking for 20 minutes, you could have some sort of evaluation to understand how it is going on. All right. Okay, very good. Well, I normally talk very fast, but I'm also trying to slow down myself just to make sure that we all are in a good pace. But it looked like that we are. Thank you for your replies. So yeah, any other questions other than what we've covered, or any question regarding what we've covered? I also apologize for my voice. I lost it for a few days. I hope your next lecture, which is next week, I get better. But yeah, so we will see. Okay, so no other questions. All right, very well. So I'm gonna stop my camera and need to change my settings a little bit so that we get ready for our lecture. So let's go through the introduction. So just give me a second. I set up my desk. So the goal of cryptography, as it says, it is an object. If you look at it in a software perspective, that its goal is to protect the other objects. What does that mean? So let me introduce you two of our members for this class that we are going to talk about them a lot throughout this class. So these are our honorary members. We have Alice and Bob that are going to be your example throughout this class. Sometimes I refer them as a person, but you can always substitute Alice and Bob as two applications. Sometimes you're talking about web applications. For example, Alice is a browser and Bob is a web service, right? So Alice requests something from Bob and Bob would respond it to Alice. But to just keep it fairly simple for us to have a better understanding, I'll go with this example of Alice and Bob with the knowledge that you can always replace them with the sort of application processes or whatsoever in the computer science world. So sometimes Alice wants to send some message M to Bob. So the story is that Alice doesn't have a direct physical connection to Bob. You can imagine Alice wants to share a secret message with Bob, maybe some romance message, or maybe they want to set up some dating. And of course, Alice and Bob don't want anybody else to know about it. But the truth is that when you send that message on the internet, you don't know where your message is being routed until it gets to Bob. And internet is a network that we call it an insecure network. So that means that anybody that is on the line in the internet, they will have a chance to see these messages. So that allows me to introduce the third honorary person in this class, and we call him Eve. No offense if somebody's name is Eve, but we're gonna use the name Eve as a name of attacker throughout this class. Eve is somebody that is interested to know what Alice and Bob are talking about. or sometimes Eve want to change their messages. And he has a lot of illicit goals in his mind, and we are going to use cryptography to make sure that he won't be able to achieve his goals. So now that we've seen an insecure network, so allow me to elaborate a bit more. So if you happen to use some software called Wireshark, I'm not sure if you guys have heard about Wireshark. How many of you guys have heard about Wireshark? Let me write it down here. If I can get to the chat with my pen. How many students have heard about Wireshark? Okay, some heard some VPN or something, not really something, but not even a VPN. No, we are talking about Wireshark. So a Wireshark is an app, is actually a free app that you can just go ahead and download it now. And once you download it and you run it, what it does is that normally in the network, a lot of packages are being sent and received, and your network card adapter would only pick up those messages that are related to the MAC address of your network card adapter. But when you install Wireshark, then your network card adapter, you're pushing your network card adapter to capture any packets that is going around. I'm saying going around because maybe you're using Wi-Fi. So in that case, your media is air, and the packets are flying around. And once you download and install this app and you're connected to the network through wireless LAN, and you run the software, then you will start to download all bunch of traffics, all bunch of packets that are going around. So the purpose of this software is to allow some people to do some analysis. But of course, if all the people, I mean, most of the time, it doesn't end up to be just analysis, and people would use it for malicious purposes. So you can download this software that I'm just giving you an idea that how easy it is for somebody like Eve to read all the packages that are being sent and received. One of the very good practices that you could do if you are in your lab, your lab is probably connected through LAN, through like a cable. So you can download this app and you can run it. And then when you run it, you will be able to capture and see all the traffic that your lab mates are sending and receiving through the gateway in your lab. And then you will realize that, well, when I'm talking that somebody, Eve, can read the messages on the internet, on the network, it is not something that is very difficult. You already have it, and it's very easy to achieve. At least you do it in your scale, which is in your lab or in your building. When you go to some higher network, like imagine you run this software in an ISP, internet service provider. In Taiwan, it could be like Zhonghua Dianxi, like it would be Taiwan Takata. Imagine you are there and you run this software. So tons of millions of users send and receive their traffic through that network. And if you happen to run this Wireshark, then you can download the huge amount of messages. So giving you an idea that, how easy it is for somebody like Eve to read the messages. But I think you would be surprised that once you run this software on your lab, you will realize that a lot of traffic that you capture from inside your lab, you can't read the content of a lot of them because a lot of them happen to use encryption. And that's why you can't read the content. But if some legacy software or somebody, using some software app that doesn't have a proper security, then you will be able to see the content of those messages. So there you will, I hope that now you really start to appreciate how important is cryptography. And if you don't have it, then it is very easy for people to see the content of your traffic. It is not a hard task at all. So we said that the goal of cryptography is to protect the other objects. So let's put that in the picture to really understand what does that mean to protect. Suppose that we are trying to create a project. So if this is your stack on your operating system, and below is like some network layers. Let me introduce you a cryptographic library called OpenSSL. And you can have a bunch of different apps, APP2 and APP3. And then here maybe is maybe TCP/IP, IP protocol, and so on and so forth. So suppose this is your how your OS would look like. This is the OS stack, and you have your networking layers on the top of each other. And then what we've used is the OpenSSL on the top of the TCP/IP, because we know that if Alice just sent a message to Bob, you need to protect this message M. If you use a TCP/IP connection, then you can't protect that, because TCP/IP will just transmit the message for you. But which means that before you do this transfer, you need to use some other library or some other object to allow you to add this protection. And one of the common examples that we would use in practice is a library called OpenSSL. I mean, depending on your operating system, some operating systems, they also have by default some different libraries, but it is one of the common ones. So the story is like we said that cryptography is an object to protect the other object. So looking into this OS stack, I can imagine that I have different objects, some of them to be app, and I have another object, OpenSSL, that helps this app to secure their communication. So this is what we mean that cryptographic is just an object to protect the other objects. So an object is a software, is a piece of code, is a library. So one way or another, you could see how it works, and this is the goal. So the goal is to just be in the interface between the application, the cool things that you will develop in the future, and the legacy things that we have in our operating systems. I shouldn't say maybe legacy. The normal, functionality that we have in our operating systems, and then the OpenSSL or some other library can bridge this gap so that you can have that transmission, but you add security to it before you do the transmission. And how would you want to do security, and how would you want to protect this messages? This is the course that we would go through it. We would see in different occasions. Sometimes you want to check the message M to not be read. Sometimes you want the M to nobody be able to change the message M, and many different stories that we would go through them together. So in this course, our objective is, of course, to design and analyze some cryptographic objectives, some of them to be primitives, and some of them are protocols. And we want to see how do they work. And again, we want to analyze their security to see how secure they are. Not everything that is proven to be secure can actually be used in the practice. We have some cryptographic systems that we use some specific ways of proof that, if you heard about it, we call it security proof of security with Oracle model. And those security algorithms, even though they have proof of security, but because of using some notation of random Oracle, you can use them in practice, because they can be secure as long as we have some promises that comes with a random Oracle model, but you could never assure to have those when you use them in practice. So those crypto systems would always remain as a theory. And only a few of maybe if we see a whole subset of ideas and algorithms out there, few of them would make it out to become practical and find a way to be in a standard protocol. Some of those algorithms that you have heard their names, RSA, AES, and maybe DES very long time ago, those were the algorithms that happen to fight and show that they can remain secure even in a standard model or in practice, and that's why we got them out there as an algorithm. So besides that, we would go through and define some security definitions, and we would, with those definitions, we would be able to prove these objects. In terms of the background that you might need, it is not mandatory to have. Knowing a little bit about cryptography would be very good, but if you don't need to be worried about it. We would try to cover everything. You will have to have some common understanding about computer algorithms. I think most of you have taken the course algorithms, yeah. And you are aware of complexity, the notation, the big O, and those sort of things. And if you happen to know them, you're again good to go. If you don't know the big O notation, the complexity of an algorithm, I would invite you to read some small material to understand what are those. And in some cases, we want to discuss the efficiency of the algorithms. And of course, always we want you to have some common understanding about probability. I think the probability that you have learned in high school would be enough. We would have some discussions, and sometimes for the security of the systems, we want to use probability to prove them. And I think most of you should have enough knowledge about the probability, so there's nothing to worry about it here. But if you don't, I recommend you to, again, start to read some small materials about probability, independent variables, and things like that, so that you will understand most of these materials. And when we get to the security proof, things will start to make sense for you easier. Any questions so far? All right. So now that we talk about the basics of what we need, so let's talk about the objectives of cryptography. So we said that is the object, that its goal is to protect the other objects. But one of the good things to discuss is the objectives, to be very specific on what cryptography can do and what is its goals, and maybe things that remain out of this list for us is things that we don't cover on cryptography. I think I would like to actually have a break time here, because I am afraid that I would start this page and we won't be able to land to anywhere to the end. So how about we have a break and we come back at 9 o'clock to continue the class.